So we continue on absorption of carbohydrates. Absorption of carbohydrates. Now, the end product of digestion, after we are done with digestion within the tract, after our complex food has been broken down into smaller, tinier particles that are carried into the blood. Of course, we said this is the process we call absorption, whereby tiny food substances or digested food substances are carried into the blood. Now, what are the end products of carbohydrate digestion? Majorly, we have glucose, we have fructose, and we have galactose. But it is worthy of note that by the time you are done taking, if the food I took was maybe gari, which contains only the form of carbohydrate we have in gari is starch, and then we are done taking that meal to the end. By the time you are done breaking down, the only thing you can have from starch will be glucose. Likewise, if it was glycogen from meat, by the time you are done breaking down, the only thing you can have is glucose. The only time we should have fructose coming on will now be if we were taking a sugary food, and then we could only have galactose if we were taking milk, which contain lactose. So the end product of digestion of carbohydrates is glucose, fructose, and galactose. Now, they are transported into the blood, a process called absorption. But how does absorption work? The absorption of carbohydrates, of these end products of digestion of carbohydrates, which are actually water soluble, cannot be done. Like we've established in our former series on membrane physiology, it cannot be done by simple diffusion because they are water soluble. Rather, the diffusion, the kind of way it is done is either through active transport or passive transport. Remember, these are the two ways, that's diffusion. These are the two ways any particle can be transported across a cell membrane or any substance. Now, active transport here, it's by a particular transporter, specifically it's a secondary active transport, by a particular transporter we call sodium-dependent GLUT1. Sodium-dependent glucose transporter 1. And then our passive transport is by, it's actually facilitated diffusion. So I repeat myself. Now, after these guys have been broken down, they are carried into the blood, a process called absorption. But we need to learn more. What means are they carried in? First, they are water soluble. So because they are water soluble, they cannot pass freely across the cells. Of course, when we mention GI wall, GIT wall, that is actually different cells. So they cannot pass the membrane of the cells of the GIT because the membrane is lined by a bilipid layer, which is selective, allowing only lipids to pass freely. So how do they go in? Now, the mechanism by which they go in is carrier proteins called glucose transporters. And we have different kinds of glucose transporters. We have from GLUT1 to GLUT7, which are all facilitated, which all carry out facilitated diffusion, which will be under passive transport. So we'll be having facilitated diffusion. But aside from facilitated diffusion, we also have another one which is actually active transporter, a glucose transporter we call sodium-dependent glucose transporter 1. Within the GIT, this guy is responsible for absorption of glucose and galactose. Within the GIT, sodium glucose transporter 1, sodium-dependent glucose transporter 1 is responsible for the absorption of glucose and galactose. And it is important you take note that galactose is absorbed faster than glucose, whereas the absorption of fructose is by a transporter we call GLUT5. So let's expand in a bit in absorption. So if this is, of course I mentioned GI wall, but this is what I want you to have as an idea of what a wall is. So if this is my lumen, if this is the lumen of the GI tract, when I go to the wall is actually different cells joined together. And then outside I have the blood. So I have my lumen here, and I have my GI wall. So different cells. Now every cell should have their own membrane. The membrane closer to the lumen is called the luminal membrane. Then the other membrane is called the basolateral membrane. Luminal membrane can also be called apical membrane. Now let's go on. Now at this membrane, we have transporters. And the major transporters of concern, one is a sodium-dependent glucose transporter that supports the reabsorption of both glucose and galactose. Then the second one is GLUT5 that supports reabsorption of only fructose. So we have here sodium-dependent glucose transporter 1, which is this guy here, absorbing galactose and glucose, but majorly, okay, the main guy is glucose, but if we had glucose and galactose in the GIT, the one that will be absorbed faster will be galactose. So it's the fastest. Now after galactose, we have glucose by the same mechanism, active transport, secondary active transport. Then we now go to fructose, which can be absorbed by GLUT5. And of course here it is actually facilitated diffusion and passive. So all of them require carrier protein. But of course why this one is active is because there is energy. There is energy involvement. And this energy is because of the presence of sodium. So the concentration gradient of sodium that allows sodium to go in allows them to follow suit. Now at the basolateral membrane, all of them return back by way of GLUT2 into the blood. So whatsoever was being digested here, glucose, fructose, galactose, which is the end products of my digestion, are carried into the blood by means of transporters called glucose transporters. And I've mentioned about the types of glucose transporters we have. We have sodium-dependent glucose transporter 1 found within the GIT for the reabsorption or for the absorption of glucose and galactose. Then we have from GLUT1 to GLUT7. Of all of them, GLUT5 is also found in the GIT for reabsorption of fructose. GLUT1 is found in brain. It has nothing to do with absorption. And then likewise, we have GLUT2 here that helps after they are brought into the cell. They now carry from the cell to the blood by way of GLUT2. And of course, from the blood, they are carried to the liver, hepatic, portal vein, if you watched our previous video, to the liver, from liver to other parts of the body. So that rounds up absorption. That's all about absorption, that when we are done digesting our carbohydrates, of course, one of these mechanisms has to be carried out based on the form of food or the end product of digestion. And once they are now moved by their respective transporter into the cell, they are carried into the blood by GLUT2. And please remember, the one that is the most or the fastest to be absorbed is galactose, if present, and then followed by glucose, and after that we now have fructose. So thank you very much for joining us today.